Okay, welcome everyone. Thanks for joining me. Great, glad you can hear me. Again, I'm going to keep everyone muted just so we don't have a whole bunch of background noise, so you can hear my voice and not have to listen through any white noise. Our goal is to help you study for the OGT. Great, glad you can hear me, Marlene. I'll be having at least one session a week until June. A lot of you, I'm not sure how you can put your name. I'm not sure if you're using the computer app or the phone app. I assumed when you logged in that it just asked you to put something. It's not a huge deal. If you want, you could just send me a chat with your name and then we'll know who you are for the rest of the lesson. So a lot of you are prepping for the OGT in June. If you do have any questions about like where you go to take the test or when the test will be, great. Thanks for joining us, Christine. The testing coordinator is Amy Wright. You've hopefully heard from her. And her email is amywright@graduationalliance.com. So if you need any questions about when and where the OGT will be or which tests you need to take, those all go to Amy. She's in charge of coordinating all that. I'm the math teacher, so my goal is just to help you prepare for the math. So we're going to try and get an overview of everything. We do only have a month, so we might not hit every single topic. If you have any particular weaknesses, you can send me one of those Remind 101 messages, and you can say, this is a topic I'd like to see at some point, and we'll try and get that covered. So I was going to focus at hopefully more of the beginning. We're going to start with real number groups. This is from a topic called Number Sense. They group all the different topics on the OGT by kind of category of what kind of topic is it covering. So our first topic is this real number groups, and it's taking numbers and splitting them into groups by their properties. A good example is if you're like counting people, you could never say that you have 1.5 people. That just doesn't make sense. You would have to say I have 1 person or 10 people. So that's a category that you have to consider is, well, what is this useful for? I do want to keep everyone muted, so please keep your microphone on mute. You should still be able to hear me even if your microphone is on mute. So real number groups, natural numbers are the first numbers you start teaching a child. They're the counting numbers. So they're the positive, nice integers. So no decimals, no fractions, just starting from 1 and counting up. Those are our first group of numbers. Whole numbers actually keeps those counting numbers. A lot of these groups, you keep some of the numbers, but then you add one more thing to it. Whole numbers will include 0, but keep those counting numbers. Because they didn't actually think of the concept of 0 until much later. It was easy to count. I know I have 1 of something, but knowing the concept of 0 came later on, so that was a new group and a new concept. And then after that, they discovered, oh, I can have negative numbers. So integers are the negative, nice numbers. Again, no decimals, no fractions. But we also include 0 and all the all the natural numbers still, all the counting numbers. So if I were to say like the number 3 so far, 3 would be in all of these groups. You could call 3 natural, you could call 3 whole, you could call 3 an integer. But if I were to say negative 3, so far negative 3 would only fit in the category of integer. So some of these groups do contain more than one, or some of these numbers do count as more than one group. So rational numbers does again keep everything we've done so far, but it's going to add in those decimals and fractions. So rational has what we have, and then also you can have fractions of any sort. You can have decimals that stop. So like if you had the fraction 1/2, its decimal is 0.5, and that stops. It's just 5. There's no digits coming after. And then decimals that repeat. So that would be something like 0.33333. It just keeps doing the same number over and over and over again. On your calculator, it has to stop. Let me pull up my computer calculator really quick so I can show you what I mean. So on the OGT, you may use the TI-30 calculator. It's TI-30 X2S. I can send out a link for that particular calculator. They do provide them, but it's good to buy one just to have practice. So when you plug something into a calculator, let me go back for a second. So when you have like 1/3, that's a fraction, but to plug it into the calculator, the division bar, that bar of the fraction, is actually divide. So in the calculator, you can type 1 divided by 3, and that would give you the decimal. So it looks like this decimal stops, but it's just that your calculator can't keep going forever. So this 3 is actually going forever. This is 0.333 going forever. It's just the calculator can only go so far. So those are the main groups of numbers, and then there's one more called irrational. So it's totally different from the rest. There was a lot of repetition in these groups. Irrational is decimals that go forever but don't repeat. So one way to get these is to have a square root. So when you square root a number, like 5, again, you want to just plug it into a calculator. On this calculator, you would hit 5 and then the square root button. And again, we see that this goes all the way to the end of the calculator, which really means there's more after, but we can't see it. So there is no repetition. It's just a bunch of nonsense. So 2.236, that's all I'm going to write. It goes forever, but no repetition. So you do have to be careful. You always want to plug it into a calculator. If we had like the square root of 4, that comes out as just 2, which is not irrational. That's natural, whole, integer, or rational. It fits a lot of categories. So a lot of information, a lot of different categories. If you're not taking notes, you may want to. And I will be saving these after and sending out links to everything we've talked about, so you could rewatch the videos and you could have these notes to look at again, because it's hard to remember all right now. It's a lot of information dump. So if you're not getting it yet, hopefully we'll get some more practice. Okay. So now let's do an actual question. That was a lot of information, but now we need to apply it. What real number groups does -3 belong to? So I'm going to go back to the previous page just so we can be looking at them while we think of it. So -3, which of these groups could we call -3? Could we say it's natural? Could we say it's whole? Which groups could we say -3 fits in? And so this is where I do want you to try and answer the question in the chat. Which of the numbers, or which of the groups, does -3 fit in? Good. So -3 does fit in the integer category. It is an integer. Are there any other groups that -3 would fit in? Okay. So whole and natural have nice numbers. There's no decimals and stuff, but they only have the positive 3. So they have a 3, but it's positive instead of negative. That negative will take it out of the natural and out of the whole category. Good. It is also rational. Okay. And that's why we do questions, to hopefully clear up any misunderstandings. So -3 fits in an integer and a rational, and that's all. On the OGT itself, so this was just a practice identifying, on the OGT, it's very unlikely they're going to ask just a question like this. They could, but it's more likely they're going to have you identify something about a number and then use it to do something else. They like kind of multi-step problems. So here's an example of one of these multi-step problems that might happen. Let x be a natural number. So we have to know what is a natural number, or else we don't know how to do the rest of this problem. So which expression will result in an irrational number? So there's another definition we have to know. What does it mean to be natural? What does it mean to be irrational? So for our natural numbers, what kind of numbers counted as natural numbers? 1, 2, 3, 4, all the counting numbers. Good. So when you have an expression and you're trying to figure out what it's going to become, I always pick one. It's really hard to look at this expression and know, well, what's that going to really mean? So from our natural numbers, we're going to pick one. We know they're this category of 1, 2, 3, 4. We're going to pick one and plug it in. And I'm going to pick literally the number 1 because it's easier. The smaller the number is, the easier it is to use. So we're going to pick 1 and we're going to plug it into our expression to see what kind of number comes out. So for our first problem, if we plug it into our expression, we replace x with 1 and we get the fraction 1/3. Again, it's hard to work with fractions or radicals, but radicals meaning these square roots. But we can use our calculator to simplify this and get a decimal. When we're trying to compare stuff, always get it to its decimal format. So we talked about how to plug this in. We said the fraction bar really just means divide. 1 divided by 3 is 0.333 repeating. Running out of room. Let me move stuff around really quick. It's not what I wanted to grab. Okay, maybe that's not going to work. I am going to write it up here since I ran out of room. So our question is, for answer choice A, is that irrational? Is 0.3, that decimal that keeps going forever, is that irrational? Okay, it does go forever. Part of being irrational was that it's infinitely long. So we have 2 people. We have a couple people saying yes, a couple people saying no. Let's go back to our definitions. So rational or irrational, there is only a small difference between the two. Rational, the decimals could go forever, and irrational, the decimals could go forever. But rational decimals have to repeat, and irrational decimals don't repeat. So now that we've clarified those 2 different things, rational, they can repeat, irrational, they don't repeat, is 0.33, that's repeating forever, is that irrational? Okay, irrational should not repeat. We have to be very careful with those little details of math. Irrational, because they're so close, they sound very similar. Irrational sounds like the word rational. The definitions are very similar. They go forever, but this is rational because it repeated. and we wanted it to be irrational. So answer choice A is not our answer because it was not irrational, it was rational. Does that make sense? Like I said, it's so very close. Sometimes it's hard to see the difference between those two little things. So hopefully that makes sense why answer choice A was not our answer. So now we have to try answer choice B. Sometimes we've got to plug in a whole lot of stuff. So answer choice B, which will result in an irrational number. We square root 1. We're plugging in 1. So when we plug in 1, okay, I just realized something about this question. This was a question I made up myself, and I didn't consider a small detail. There actually is no correct answer to this. So I'm going to switch which one we're picking. I'm going to pick 2 instead to show a correct answer. The OGT will not have any mistakes because they have multiple people making these tests. Unfortunately for me, when I'm coming up with these questions, it's easy to make a mistake. So if we use 1, there's actually not going to be a correct answer. If we use 2, you'll see a little bit of a difference in some of our answers. I apologize that I'm going to have to change the question. So if we use 2, answer choice A will still not work, but it's going to affect how answer choice B works out. I apologize again that I had a wrong question. There's so many details to think of that when you try and write a question like this, it's easy to make mistakes. So square root of 2. We're going to pick 2 to plug in so that this works out better for the question. If we plug in square root of 2, again, we want to utilize our calculator and actually plug this in to get the decimal. So when we plug in square root of 2, we get 1.41 213. This time there is no repetition. So when we plug that in, is this irrational? If we get a decimal, yep, so Lisa is correct. This is irrational. And once we've identified the correct answer, we don't necessarily have to keep going. You can if you want, but you can just stop and say, now I know what the correct answer is. So instead of giving you like an actual expression to work with, they can also just play with the definition and say something like this. Which word best completes the sentence? All integers are also this type of number. So again, this is more about knowing this definition. What does it mean to be an integer? Very good. I'm going to try and say your name, but I'm sorry if I slaughter it. Shakwala, very good, Shakwala. And Christine, good. Integers are also rational. Integers were our group of negative numbers, all the negatives, 0 and positives, and rational included that whole group too. Rational was that group and a couple extra things. Good. Yeah. So there's some other ways to group numbers, and these aren't usually defined as formally as, natural whole, but we still need to know what do each of these things mean, because they're going to give us questions where they assume we know what's positive, what's odd. So positive numbers, those are basically those natural numbers. 1, 2, 3, well, sorry, let me qualify. So those natural numbers, but anything in between, as long as it's above 0. You could also have any decimals. 1.5 is positive. So positive is above 0. And negative is just below 0. Every type of number below 0. So it could be negative fractions, negative decimals, negative integers, positive above 0, negative below 0. Odds could be positive or negative. Their odds are 1, 3, 5. You go up by 2, but what makes something is sorry, sometimes my tongue gets tied. What makes something odd is that you can't divide by 2 and have a nice answer. So negative odd numbers are still odd. Evens you can divide by 2. So 2, 4, 6, 8. And still negatives also considered even. As long as you can divide by 2, it's considered even. And perfect squares, those are those square root numbers that don't come out as decimals. Square root of 4, if you plug it into a calculator, is 2. That's a perfect square. 4 is considered to be the perfect square because it came out nice when you plugged it into a calculator. 5 would not be a perfect square because it comes out as a weird decimal. So again, these are all definitions we need to know because they're going to ask us questions involving these definitions. So let's go to another example problem. If x and y are both even numbers, which expression results in an odd number? So again, they just need us to know these definitions. They assume you know what it means to be even. They assume you know what it means to be odd. So for our even numbers, when we have these expressions, it's always easiest to pick one. Pick one, plug it in, then see if you come out with an odd number. So for x and for y, what even number should we pick? What even number should we plug in? 2. You can really pick anything. I know it seems limitless, but you can pick any even number, but 2's small, so it's easier to work with. So we're going to do 3 multiplied by 2. This is also something they assume you know. When you have a number next to a letter, they assume you know that you're really multiplying. There's a multiply sign there. So when we plug in 2, 3 times 2. Then we're going to just use the same number. They just said they had to be even. So let's try 2 for y. It's nice to just pick smallest even number because it's easy to work with. And then we have to simplify this. So when you simplify something like this, you have to follow the order of operations. You've probably heard that at some point. Order of operations, which they sometimes say PEMDAS, because we must do this in a particular order or we're not going to get the correct answer. Your brain wants it to be left to right, because that's how we read. But with math, that's not always the correct order. So order of operations, parentheses, exponents, multiply, divide, add, and subtract. We keep going in this order. We don't have parentheses, we don't have exponents, but we do have some multiply. So we have multiply here, multiply here. We have to do both of those multiplication problems before we do any addition. We want to do 3 times 2 and 5 times 2 separately from each other, then add. So 3 times 2 is 6 and 5 times 2 is 10. Once you've done all the multiplication, now you can go to the addition. 6 plus 10 is 16. And these ones are pretty easy because we picked small numbers. If the numbers start getting big or you have decimals or fractions, plug it into a calculator. Calculators are great. So the answer we got was 16, and now we have to look at the end of this question, which said it should come out odd. So did the number we get, 16, is that odd? Did we come out with an odd number? No. Good. This is not odd, so this is not our answer. If they had said, we want it to result in an even number, we'd be done, but they said an odd number. So now we try again. We're going to just keep the same numbers. We're going to replace x and y both with 2. So 2 times 2 divided by 2. Order of operations with fractions is weird. You have to do the top separately from the bottom. The top gets its own PEMDAS. The bottom gets its own PEMDAS. Then you can do the division. There's not much going on here, so the top, all we have to do is multiply. 2 times 2 is 4. There's nothing to do on the bottom. There's only one number. Then we can do the division. So we come out with 2. 4 divided by 2 is 2. Again, we ask ourselves, did it come out to what we want? We wanted odd. So is this our answer? Did it come out odd? Nope, still even. Good. Then we try again. So C is xy minus 1. Again, just like 3 times x, that was multiplication. A letter next to a letter is multiplication. I should have pointed that out up here. xy was 2 times 2 because you had a letter next to a letter. So here we do 2 times 2 because there's really a multiply sign in between. And again, order of operations, we have to do the multiplication before we do the subtraction. So we get 4 minus 1 is 3. So is that our correct answer? Did this come out odd? Yes, good. So again, once you get the correct answer, you can stop. On the OGT, probably 80% of it is multiple choice. There are those few free response, and we'll get to some of those types of questions. I don't have any free response questions today, but for the most part, with the multiple choice, once you find the right answer, you can stop. I do want to point out down here at the bottom what these are. These are absolute value bars. With absolute value bars, once you do everything inside, I'm not going to pick 2 and 2 this time. I'm going to pick 4 and 2. 2 and 2 would come out as 0, which is not really either even or odd. So I'm going to pick 4 and 2. If we plug those in, 4 minus 2 is 2. You do what's inside first. Then we take the absolute value. Oh, sorry, will we see those on OGT? Absolute values, yes, they will have some absolute values involved in the OGT. I'm trying to pick all topics that would be actually seen on the OGT. Good question. So absolute value bars, what they do is they either keep the number positive or they make the number positive. This was already positive, it comes out positive. If the order had been different, if it had been 2 minus 4, we'd get negative 2, but it still comes out positive 2. Absolute value bars, your answer is always positive. That's what they do. They make the answer positive. And feel free to ask questions as we go. If there's anything I'm going too fast on or you have a question on, feel free to type it into the chat box and we can talk about it as we go. Okay. So one more of these kind of expression questions. This time, instead of actually giving us a group, they didn't tell us it was an integer, they didn't say it's positive or even. What they said is let x be greater than 2. So this inequality symbol here means greater than. Which expression will result in a value less than x? So you see me underlining a lot on these. It's always good to identify what are they asking, what's the actual answer I'm looking for, and what's the important part of the question. So sometimes with these long sentences, it helps to really focus on what's actually important about this, what will help me solve this problem. So if they say x greater than 2, they want a number bigger than 2. So when we pick our value, we have to pick something bigger than 2 because they told us so. That's the type of number they wanted us to use. So if we pick something bigger than 2, what should we pick? Six would work. Anything bigger than 2. A number bigger than 2. So let's pick 6. So we're picking 6. And this time, before we plug it in, let's think about how that's going to affect our answer. They said a value less than x. Well, specifically, we picked x to be 6. So this will make it have a little more context. It's hard to know what they mean by a value less than x, but we do know what it means to have a value less than 6. So now we know when we're plugging 6 in, we want our answer to be less than 6. And then we just have to go answer choice by answer choice again. So answer choice A, we have to know that this is really multiply in between 3 multiplied by 6 to the 4th. So this exponent has to come before multiplication. We do not do 3 times 6. We have to do the exponent part first, still following that PEMDAS. And exponent comes before multiply. So this means to do 6 times 6 times 6 times 6. So multiply that out 4 times. Or the calculator has an exponent button usually. I'm going to see if I can get a way to do the actual OGT calculator, but I haven't found a good way to do that on the computer yet. So for now, I'm just using this one, 6 raised to the 4th power. And you'll see this little kind of triangle button. That's what would actually be on the OGT calculator. It's 1,296. So 3 times 1,296. Now we can do the multiply part. Get 3,888. So we always now go back to what they were asking for. We wanted the value to be less than 6. So is this the correct answer? Would this answer be less than 6? Nope, it's way, way, way bigger. So that's not our answer. Good. So now we do the next answer choice, x squared plus x. We're going to replace each variable with 6. And we follow the order of operations again. 6 squared. Either you can type in 6 times 6 or you can use the squared button. Clear this out. So you can just do 6 times 6, which gives you 36. So 36 plus 6. Now we do our addition to get 42. Is this our correct answer? Is this going to give us an answer that's less than 6? Since we picked 6, good. This is also not it. So then we try the next one. Square root of 6 plus 5. Square roots count under the exponent category. They still need to be done before the addition. So square root of 6 needs to be typed in first. 2.4, I'm going to just approximate as 2.4. And then we add the 5, so 2.4 plus 5 is 7.4. So again, now we ask ourselves, is this the answer? Does this give us a value less than 6? Still no. Good. So then D has to be our answer. If you want to plug it in, you can to be sure. You can always double check by plugging it in. We already know square root of 6 is 2.4 since we plugged it into the calculator. Oops. And then 2.4 minus 5. It's super easy to make little mistakes like that. I put plus 5 because that's what we did on the last problem, but I should have put minus 5 because that's what we're doing now. So you have to watch out for that because it just happens to everyone all the time. Got to be super, super detailed. Sorry, I think I typed in the answer instead of 2.4 minus 5, which is negative 2.6. And that being a negative, negative 2.6 is definitely less than 6. Good. So I included this one because now we have some fractions going on. And I know that most of you probably hate fractions because honestly, everyone does. Everyone hates fractions. It's just kind of a common denominator of math. So what is the value of the expression AB squared divided by C if A equals 1/2, B equals -4, and C equals 3/4? So my solution, because you hate fractions and so does everyone else, is to not use fractions. If we can help it, we don't want to use fractions. I know the answers are in fraction format, but we can still figure out our correct answer even if we get an answer that's a decimal. So what we're going to do before we plug these in to the expression, we're going to make them a decimal. So 1/2. When I plug it into the calculator, what button do I use to change this fraction to a decimal? What math button did I do? Plus, minus, multiply, or divide to make a fraction into a decimal? Division. Good. Yep, divide. That fraction bar is really divide. So 1 divided by 2 is 0.5. Good. Yep, it is division. B is not a fraction, so we don't need to worry about it. C is a fraction, so 3 divided by 4. So now that they're decimals, we don't have to worry about the fraction part. We plug it in, we replace A with 0.5. This is multiplied by -4 squared over 0.75. So order of operations, you have to do on the top and the bottom separately. The fractions were kind of weird. So on the top, there is an exponent, -4 squared, which means to do -4 multiplied by -4. It's always best to do these the long way and to not use the exponent button when you have a negative. The reason why is if we do -4 using the exponent button and square it, oh, I guess this calculator's fancy. A lot of the calculators would tell you -16, but if we do -4 times -4 separate, comes out positive. And the OGT calculator, it's better to do this multiplication. So whenever you have a negative number to an exponent, better to just multiply it out. So that gives us 0.5 times 16. Then we do the multiplication. We do exponents and multiplication next. Times 16 is Something else to watch for is if you're too quick and you miss something, I hit 5 instead of 0.5, you're gonna get the wrong answer. So make sure you're typing everything in correctly when you do use your calculator. And now we do the division. 8 divided by 0.75 is 10.66666, repeating forever. Okay. And it does show at the very end a 7. That's again because your calculator can't keep showing 6s forever. It rounded here, even though it's really 6 going forever. So now we look at our answer choices. Which one is the correct answer choice? Even though it's written as a fraction, there's only one of these that starts with the same beginning 10. So answer choice C. Good. So every time you have fractions, it's better to just move them to decimals. Almost every time. Almost every time it's better to use decimals because it's easier to work with. Fractions are just tough to work with. So this one is asking you which sequence of numbers is equivalent to 25%, 1.6, 1/5, 3. So they're saying which of these is really the same list of numbers. And it's still all about using our calculator for the most part. 25% we'll do by hand, but we want them all to be decimals. If we can get everything to the same format, all of them decimals, then it's easier to compare the lists. Let me rewrite the list for you. Sorry that it's kind of blurry. So there's our list, and here's answer choice A. So we did have someone join, so just to catch them up, we're on a question where we're trying to see which of the answer choices is really equivalent to the list that we have written out. So they gave us the list 25%, 1.6, 1/5, 3. We just want to change them all to decimals. So 25%, you can change this to a decimal 2 ways. You can either move the decimal 2 spaces to the left, but you have to recognize really the decimal is after the 5 if they don't have one written in. Or I always remember that percents are out of 100, so 25% divided by 100% will change it to a decimal because 20%, any percent is always out of 100%. So 25 divided by 100 is 0.25. So this as a decimal is 0.25. 1.6 is already a decimal. 1/5, we've talked about how when you have a fraction, that's really division. So we plug it in as 1 divided by 5. That's 0.2. And then 3 is already in a whole number format, but we don't really need to change that to a decimal. So now we try answer choice A. I'm going to put a little line in between them just so we can see that that was our original statement. Now we try answer choice A and see if it matches. We're going to have to change each of these into a decimal. So 2/8, we do 2 divided by 8. Every fraction is really just division to change it to a decimal. So far, we match. Let's try 160%. We can always divide any percent by 100 to make it a fraction. 160 divided by 100 is 1.6. I'm going to double check that I typed that in right. 160 divided by 100. Good, 1.6. So far, we're good. 0.2 is already a decimal, and 3.00 already a decimal. So did these two lists match now that we have them all as decimals? Good. Yes, they did match. So they are equivalent. Equivalent, which you probably can't see because it was not clear. Equivalent means equal to. It's just a fancy way to say equal. Good. So another part of this topic of number sense, the OGT groups this all under a category called number sense, is scientific notation. So scientific notation is all about taking a very, very small number or a very, very big, we might see some very, very big numbers, and writing it a little more compactly. If you had something like with just too many zeros to ever really want to write out, that's why we would use scientific notation. Sometimes it's just a pain to write all of that out. So scientific notation, we're going to always have to put it in a certain format. The format is we always want the decimal to be after the non-zero number. We have a whole bunch of zeros. We want the decimal after that 7. If any of our answer choices had said like 79 times 10 to the third, that's just not right. It would be immediately something we could cross out because the decimal has to go immediately after the first digit. I'm going to send our student who just joined a quick message so that they can make sure to have sound. Oh, I don't know how that happened. I meant to have it sent to all, and I don't know how to fix that. Okay, here we go. Might have been too late. I think they just left because I couldn't get that out quick enough. Okay, sorry, back to the question. So all of these start out in the correct format, and all we really have to do is count. We want to count how many digits over until we get the decimal in the spot we want. So how many spaces do we count over to get directly behind that 7? Good. 6 spaces. So when you go to the right, that makes it negative. So when we count those 6 spaces, it's a -6. Now let's say you're doing the OGT and you forget the rules. You're like, I don't know where the decimal is supposed to go. I don't know how to write this. With multiple choice answers or questions, you can use the answers to kind of check. So instead of counting, what you could do is plug this into a calculator and see what you get. 7.9 times 10 to the -5 is pretty close, but if you count it out, we're missing a 0. So you can kind of use the answers. What does the number 10 represent? That is a very good question. It's easier if we use, so I'm going to go to a blank page. So if we have the number 54,000, okay. The reason it's always times 10 to something, so if we write this out in scientific notation, it was 4 spaces, so 5.4 times 10 to the 4th, is because basically that's how many times we would need to multiply by 10. 5.4 times 10 times 10 times 10 times 10. So we multiply by 10 4 times. So that's how many times we would have to multiply by 10 to get that actual number. If we do 5.4 times 10, that's 54. And then we still have 3 left. If we do 54 times 10, that's 540. If we do 540 times 10, that's 5,400. And if we do 5,400 times 10, that's our 54,000. So we're just finding how many times we would have to multiply by, or going back to our decimal one, the reason it's times 10 to the negative 6th, this is how many times we'd have to divide by 10 to get to our correct number. 7.9 divided by 10 is 0.79, and then we'd have to do that 6 times to get to the same number. So does that make sense as to why it's a 10 every single time? Good, perfect. Thank you for the question. I really like questions as we go through, just to make sure we're all on the same page. Great. Okay, so one more scientific. Which number expresses the same value in standard notation? So standard notation just means what you normally work with. So a red blood cell measures 6.48 times 10 to the negative 6 meters. You can either take each answer choice and count to see what it would be in scientific notation, or it's easiest to just plug the scientific notation into a calculator and see what answer you get. 6.48. And again, careful, I clicked and I missed my decimal. That can kill you on any test because it's easy to miss. 6.48 times 10 to the negative 6. So now you just have to compare. We know for sure it's not C or D. Those were not decimals like we got on the calculator. So we would just have to count how many zeros we had and make sure we got the same amount of zeros. A is correct. B is a little bit too big. If you want to be super careful, you can always count and say there's 1, 2, 3, 4, 5, 6, 7, 8. So 8 digits after the decimal. And then you could count on answer choice A, there's 1, 2, 3, 4, 5, 6, 7, 8 numbers after the decimal. So A is our correct answer. Very good. Okay. The other thing they can do is instead of just having you switch it back and forth, they might have you do some math with the scientific notation. So the diameter of Earth is about 7.9 times 10 to the 3 miles. The diameter of Jupiter is approximately 11 times the diameter of Earth. So our important number is the diameter of Earth itself. The fact that it's 11 times, Jupiter is 11 times the diameter of Earth. So in the question, there's usually some key math words that you almost have to translate. Math is like learning a new language. So when it says the word times, what math operation is it actually asking you to do? Is this addition, subtraction, multiplication, or division? Multiplication. Good. And sometimes they're pretty straightforward. Sometimes, like, they'll use the word product. You might not know what the word product means because it's not used a lot, but that's also multiplication. So one of the resources I'm going to send out when we're done is just a list of, I might have included it. Let me see. Nope, I didn't. So I'm going to send out just a list of, this is the word, this means add. This is the word, it means subtract. Just so you can kind of study and see, these are all the words they might use, and then I might have to translate into addition, subtraction, multiplication, or division. So this question is saying, take 7.9 times 10 to the third and multiply it by 11. You can technically do this by hand, but Why waste the time? You're limited on time on the OGT, plug it into a calculator. Calculators are great. So 7.9 times 10 to the third times 11. So 86,900. We only have two answer choices it could be. It's definitely not A, definitely not D, because that said 7.18 and that said 9. So we just have to see, well, what's the difference between B and C? And that's this exponent. So Marlene thinks it's B. Anyone else want to chime in? Do you think it's B or do you think it's C? Getting some difference back and forth. Is it B or is it C? So how do we tell? Let's think again about scientific notation. I was trying to change the color. There we go. We want the decimal, and they even have it in the correct place. We want it directly after the 8. This is where we want the decimal to be. And this is where the decimal currently is. It's currently at the very end. If they don't write it in, it's always at the very end. So how many spaces do you have to count to get over to where we want the decimal to be? And that'll tell us which one our exponent is. So now that we've had a little more explanation, 4 spaces. So 4 spaces means we should have an exponent of 4. Now what's our answer, now that we've got a little more explanation on this? C. Good. So our answer is C. Now let's say again, you're doing this test, you're just not sure. You're like, they're pretty close, they're pretty similar. I'm not 100% sure. Now we know for sure it's C, but let's say we weren't 100% sure. Check your answer choices. Type in 8.69 times 10 to the third. That's 8,690, and we could see, oh, that doesn't quite match. So always kind of do some double checking as you go through the test. So we're pretty much out of time for today, and that's all I had prepared for today. Any last questions? We only have a couple more minutes, but any last questions before we stop here for today? Okay. If you do think of any questions, you can always send me messages using that Remind 101 group. When you send a message back to me, it only comes to me. It's not to the entire group. All my messages, I type one big message to everyone, but if we're having a personal conversation, it'll be just between me and you, just so there's no worries about that. I'm going to upload this if you have any interest in watching the video again, and I'll send that link out via Remind 101. And then over the weekend, I'm going to decide when I want the session to be next week. I'm trying to vary what days and times so that hopefully everyone gets a chance to join. So sometimes it may not work with your schedule. We're trying to accommodate everyone possible, but there's a lot of people trying to prepare for this test. So thank you guys so much for showing up today. I really appreciate you being here. Thank you, and I hope this is helpful, and hope you guys have a great weekend too. Thanks, everyone.